information sheets, lots of material to help teachers bring this into the classroom. Because that's my biggest challenge, is getting a teacher comfortable to run a session in a classroom that is meaningful for the young person. Because it can be quite intimidating to look at, but usually what I find is after one day of tuition, the teachers are very comfortable with using it in their classroom. So all of that material is going to go online. So I have videos, how-to teaching materials. A lot of the materials that I put together are pictorial and video-based. So I try and overcome the language barrier. But I do also have some videos that have subtitles as well.
Oh, okay, so maybe can you...
Okay, so my main focus really is to teach young people how things work in the real world. So ASSMBLR is nearly 100 components. A lot of the components are real components that are used to build aircraft engines, that are used to build cars, that are used to build printers. So we have bearings, we have nuts and bolts, we have real engineering components.
Are they not real engineering components?
They are real engineering components.
What about non-real engineering? Are they non-real?
They are real. And I will demonstrate. And also real engineering processes as well. It's not just about the components, it's how you use the components, okay? So we can make very basic gear systems. This is a ratchet gear, okay? Very straightforward. We can make a internal ring gear. So these are used in escalators and elevators. In fact, these are used in electric screwdrivers as well, this gear system. And we have a cam system. So these are used widely in cars, okay? So we can teach young people how things work. But the important thing is that the child is building this. They're making this from a raw product. So everything that we have here is one standard length. We use tools to cut these to any length, which now sets this equipment apart from every other robotics kit. Because you can cut this to any length, it means that you can be as creative as your mind will allow you to. And that's how we create a society that is a good problem-solving society, and this is how we encourage young people to become engineers, because what we're doing is we're allowing them to be engineers. They have to think for themselves to a certain degree, but of course we need to guide them as well to be able to, so they have a meaningful yeah. Yes, exactly. Yeah, so measure twice, cut once. That's an engineering. You have to measure twice and cut once. You have to plan, because that's what we do in the real world. An aircraft engine isn't just a bunch of engineers who put some stuff on the table and build. No, they plan, and then they build. This is an engineering process. This is what we do. Okay? So, we also have things like bearings, metal bearings. We use these everywhere. They're very common. Okay? So, there are special holes in here, and we press fit these into the holes. So we're starting to talk about engineering processes and also physics. We can talk about interference fit. What is an interference fit? An interference fit is when the hole is slightly bigger than the bearing, but there's enough friction to hold that part in the hole. It won't fall out. That's an interference fit. That's how wheel bearings are held on car axles. That's how your wheel on your car is held on. Same as that. Okay? That's an actual engineering process. We have from our very smallest kit, this is a gear spinner. Lots of components. Let's identify them. So we're identifying what is a drive shaft, what is a chassis, what is a bearing, what is a nut and bolt, what is a gear, and how they work. From this, children can build this really nice gear spinner. Yeah. Okay. But why is this important? Well, they're not just given this, they have to make it. And there are a number of processes that are involved in making something that works. In actual fact, making something that works is a really difficult thing, and it's forgotten about. People will take something like a gear spinner or a fidget spinner, and they won't realise or understand how much time and effort has gone into designing and making that. So this is what we're doing. We're actually showing them how it's made. They understand how to push fit a bearing in. They understand what an interference fit is. They understand about nuts and bolts and different types of nuts. And once they understand how to build this very simple mechanism, they can take that knowledge and build something bigger. They can build something like this. Yeah. So this uses the same processes as that. And this is a vegetable racer. So we put different sized vegetables on top, and we run it down a ramp, and we measure its time, the time it takes, the distance it runs, and suddenly we're now talking about physics. It's meaningful content. Yeah? So for primary level, this is a primary level. This is primary level as well as secondary. But when you want to get into more advanced content, you add your motors and you add control. Yeah? So I've designed the kit to fit with 5-volt servo motors. And the servo motors are very common. They're commonly used in robotics. But it also means that you can add different programming platforms. You can add microbit, you can add Arduino, you can add Raspberry Pi. You can add anything you like. Because this, again,
Just
this,
the framework.
yeah,
You can
this,
add any
it's about making.
electronics into
It's about
it.
making. Yeah? So there's no one set way to build. There's no two set ways to build. Like many kits available, you have one thing. You buy a kit, you build 1, 2, or 3 items. This is anything. Yeah? That can come out. I've lost my nut on the end of that. So it's very creative, but also it's quite straightforward to make something as well, and to also explain how things work. So from a very simple gear system like this, just to explain how it works, but then you can make that a lot stronger, and then you can add a motor to that, and you can take it a step further